Hello, 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 hello. Assignment two here, chapter six. These are going to make you think. All right, so get ready. The first one here is about life insurance. Typically, this is something you don't really think about until you get a little bit older in life, and maybe you have a family and you are worried about what might happen to them if you were to suddenly pass away. And so people buy life insurance policies that will pay out a lot of money on the unfortunate circumstance that you were to die. This one is saying that when you're 20, they sell this policy to a 21-year-old, and if that person were to die, they would be paid $100,000. And this is good for 5 years. So when they're 21, 22, 23, 24, 25, and then it stops. Okay. Um, the probability that a chosen male will die each year is found in mortality tables, and those are these probabilities down here. Okay. You the premium is what you pay the insurance company. You pay them $250 every year. So you give them $250 in the first year. Hopefully, you are still living at the end of the year, and that's it. If you happen to pass away that year, they would pay you $100,000. And you do that for 5 years. If 5 years go by and you are still alive, well, then that's it. You paid them $250 every year. Um, so it's insurance in case you do pass away. Um, so they're calling the amount Y is um, uh, well, sorry, not, I guess I put a Y here. Sorry. Um, the company earns $250 a year, but they also have to pay $100,000 if the insured person dies. So here's the table, and I filled in the rest of it. So let me explain the first column here. Okay. Um, this is the I should say this is like it is Y, but I'm going to say this is the company's profit. This is not the individual's profit, okay? We're looking at this from the company's perspective. If they gave um, a 21-year-old this policy and that person happened to pass away, here's the probability a 21-year-old passes away. And this would be their profit. In this case, it would be a large loss because it would be they got $250 from the person, but then they had to pay minus $100,000. So that's where that first number comes from right there. And what about this one here? So this probability is from the mortality tables, meaning they've studied and have data on the probability of a 22-year-old passing away. Thankfully, it's really low. Um, and so if you've been doing this policy for 2 years, you have paid them $250 twice, and then you subtract, if the person passed away, again, you subtract the $100,000. So in that scenario, the company has lost that much money. So for this one, where did I get this number? Well, they have had the policy for 1, 2, 3 years, so $250 times three, and so they've paid the company $750. But then the company had to um, fulfill the policy by paying the $100,000. So that's that number. You can kind of see the pattern as you go here, I think. Okay. The number on the bottom again is the probability that like a 23-year-old passes away is that probability, 24-year-old. Okay. And I continue that over. Let me do the 25-year-old. If you've been doing this policy for 5 years, you have paid $250 times five. You've paid $1,250 to the company, and then in the event that you die, they pay out $100,000. So that's where this number comes from right there. Now, when you get to 26, right here, the policy is done. Okay? You don't keep paying. It says here this is for the next 5 years, right here, okay? So that means you have paid in all 5 years. You have paid in um, 5 years of $250, okay? But at this point, you are not um, insured under the policy. So the company actually makes that money, okay? They profited $1,250 because you're no longer insured. They will only pay you if, in the event that you pass away, before 25 in this scenario. To get the last probability here, which is over 99%, which is logical because a vast majority of people live to be older than 26. It says find the missing probability. I just add all of these up right here, and I subtract it from 1. Just be very careful when you're doing that to make sure you do indeed get that number. Okay? All right, so that's a lot of groundwork to do A and B. C, calculate the mean. This is also called the expected value. And I wrote out the nitty-gritty work for this. You take each outcome, okay, and multiply it by the probability of that outcome. You do that over and over, and you add them all up. You sum them. So from the company's perspective, here's your first outcome, and I put it right here. And you multiply that by the probability of that outcome right there. And then I did it again for these two right here, and so on. Do it for this one, and this one. So you're doing this 5 times. So I've got that here. 1, 2, 3, 4, 5. Oh, 6 times. Forgot about this one. 6 times. And you add that all up. I mean, be very careful. I mean, I had to do this twice to make sure I got the same answer twice. I'm not going to take the time to type it in right now, but you should get $303.35. What does that mean? In context, folks, it means on average, the company makes $303.35 per policy. Woohoo! Okay, so if you issued a policy to a person and they did this for 5 years with you, you would expect to make $303.35. Groovy. So you're like, well, why don't I always do that? Well, that's what the follow-up question is for. 18. It would be really risky to do that, okay? There's a high probability that people will live and you would get $1,250 in premiums, right? That's over here. But on the low probability that somebody actually dies, you lose almost 100 grand. So explain why this is not well, then why do insurance companies do this? Why is this not risky for an insurance company? And that's because the company is relying on the law of large numbers. If they only insured one person, that would be incredibly risky. Your benefit, you stand to gain $1,250, but the worst case scenario is you almost lose $100,000. Whoofta. But if you are doing thousands and thousands of people with different policies, there will be an occasion here and there where you do lose 100,000, which is terrible. But you have all the other thousands of times that you profited the 1250 to balance it out. Actually, I should retype this. And so then on the policies they don't have to pay out, they will profit 1,250 on thousands of other policies. All right. B, the risk of an investment is measured by the standard deviation. Okay, so it's asking us to find the standard deviation for this situation. Let me explain the formula that I've got here. We wrote this in your notes the other day. Standard deviation is the square root of sigma of each x value minus the average squared times the probability of that outcome. Okay, now I'm doing that here. Okay, so I take each outcome minus the average, square it, multiply by the probability of that outcome. Sigma means I add all of those up, and then the final thing I'll do is square root it. Okay, so I have done that. Let me show you. First outcome is this. How far is that from my average? My average was, my expected value is 303 and 35 cents. You then square that from the squaring right there. Then you multiply that by the probability of that happening. It's kind of weighting that. How much significance should this value have? Well, it doesn't happen that often, very not likely, so we scale it down. And I do that again and again for all of these outcomes. So I wrote down the second one, or I wrote down the last one, I should say. The dot, dot, dot means I skipped these four, and I just went straight to the last one. So the last one, what's the outcome? It's they earned $1,250. They again subtracted the average of 303.50. They squared it and they multiplied by the probability of that outcome, which is over 99%. Okay? This takes time, guys. Put it in the calculator slowly. Be very careful. And when you do that and add them all up, you get this number that's over 94 million. This would be the variance. Okay? I have not yet square rooted it. So if you do square root it, oh, where'd that number go? Come back. You'll get the standard deviation. 94,236,826.64. Okay, that is the standard deviation, which I have right here. Okay, so we found the standard deviation. It's over $9,700. So considering that our average profit is only $303, this is a very risky agreement because it means on average, you would expect your profit to vary from $303 by $9,700, which is just very scary. And considering what if the policy goes well for the company makes 1,250. On average, that's going to vary by $9,700, which is bad. Okay, so it's risky. Number 23. Moving away from life insurance, going back to standard deviation and z-scores, folks. So this is normally distributed. The average is 6.8, and the standard deviation is 1.6. Okay. This, by the way, is a continuous variable because you can get any score in this range, any increment along the way. You could get 6.8, you could get 6.3, 4, 5, 9, for example. There's any possible outcome. The question is, what's the probability that you get a score greater than or equal to 9? Okay. So greater than or equal to 9. So here's my sketch. 9's right here. This goes way back to chapter 2. You need to find the z-score for this outcome of 9, and then look it up on the green packet on table A. So you take your score, 9, minus your average, divided by your standard deviation. So you have a z-score of 1.38. Remember, in the middle, the z-score is 0. So 1.38 would be the z-score for 9. Okay? In the packet, let's see if I can find my green packet for you guys quickly. I might be doing some searching here. Oh, where did I put it? Here we go. All right. You're looking up that z-score. What was it? 1.38? Sorry, I've got some other stuff on here to get rid of. Okay, I'm looking for 1.38, which is here and here. So it looks like this. 0.9162. And notice, guys, that's this side. That's the left side. That's the less than side, because 1.38 would be here. Okay, so 0.9162. Whoop. So that's right here, right? So this left side is 0.9162, but it wants me to do the greater than or equal to side. So I did 1 minus that. So what does that mean? That means this blue side over here, the small side, is 8.38%. So there's an 8.38% chance of a student's score being higher than 9. All right. This one's about voters. They surveyed voters and asked them, no, they studied the records to see if they voted. And 56% of them actually had voted. Okay. We'll see in a later later chapter that in repeated samples of this size, the proportion in the sample who voted will vary according to the normal distribution with this and this. Okay. This is the standard deviation. All right. So this is back to the normal curve. The average is in the middle of 0.56. They want to know the probability of being between these two red bars, 0.52 and 0.60. Okay, so I need to find a z-score for both of these, which I've done right here. Take your time and look at that. Pause it and look at that, and you get they're opposites, which isn't surprising because they are equidistant from 0.56. That's 0.04 that way, that's 0.04 that way. And then look these up in table A to get the percentages on the curve. So I need to look up negative 2.11 and 2.11. And I'm going to get this green number and this orange number. Let me show you. So this one would give me the 2.11. 2.11 is right there, 0.9826. And then negative 2.11 would be, oh, sorry, here's this one. We got to go back to here. Sorry for my mess there. Negative 2.11 there's that 0.0174. Okay. So that's where I got those two. You just have to know how to use them, right? So we want the red in the middle. So from here down is 98%, and from here down is 1.7%. So you subtract those two to get your final answer. Part B says, in fact, in the survey, or in that sample, 72% of the people said they had voted. Maybe they asked them, did you vote? And 72% of the people in that sample said, yes, we did. And then they looked at their records, and in their records, it says 56% of the people voted. So if they were answering truthfully, what's the probability that this would actually be the case? Okay. So if 56% was the correct center, what's the probability of 72% of the people saying they had voted? What's that probability? In other words, what's the probability of getting a sample of people where 72% of them had voted? Okay, because they know from records that the true percentage was 56. Is it possible to get a sample 72% or higher? in this scenario. Okay, so we take, and here's what the notation would be. The voter percentage was greater than 0.72. So I found the z-score for 0.72, right? Subtracting the average, dividing by 0.019. 0.019 was the standard deviation. And that's a z-score of 8.42. And that, the probability of a z-score being greater than 8.42 is nothing. If you look at table A, it stops when z gets to 3.49. So there's no data out there. When you get way out here in the curve, there's nothing, okay? So what that means, you guys, is if this was the average and you randomly sampled people, the probability of getting a sample this far out on the curve is pretty much zero. So it's pretty much saying that the people were not answering truthfully. So that some people who did not vote claimed that they did vote. So they overrepresented their probability that they voted. Yep, it would be virtually impossible to get a sample in which 72% said they voted if 56 was indeed the average. Okay, 29. Decks of cards. If you want to gamble on cards, here's a problem for you. If you gamble on an ace being drawn, you're going to win. You get 10 bucks. If an ace is not drawn, you lose your dollar. Okay? So this table here summarizes this, but this is the hard part, just even creating this table. So when you draw, there's an outcome. You either get an ace or you don't get an ace. Okay? The profit on an ace is you win $10. Woohoo! I should put a smiley face next to that bad boy. If you don't get an ace, you lose your dollar. Oh, frowny face. Okay? Now we need to have the probability associated with each of these. So what's the probability of an ace? Well, in a deck, there's 4 out of 52. So that reduces to 1 out of 13. So you will win this game 1 out of every 13 times you play. That means you will lose 12 out of every 13 times you play. Is this going to be worth your time? Because the question is, what is the mean or the average? So you take each outcome. In this case, maybe outcomes, be careful. It's not this one. You take each profit. Okay, that's your profit times the probability of that profit. So $10 is nice, but you only get $10 1/13 of the time. Plus, you lose a dollar 12/13 of the time. When you do this calculation, you get negative 2/13, which is negative 0.15, which means on average, you will lose about 15 cents. 30, they just change it up. They give a different bet. You're not betting on aces anymore. You're betting on hearts. Okay, so hearts and not a heart. But now you don't win $10, you only win $2. So it's very much the same table. It's just that now we're doing hearts and you only win $2 instead of $10. Okay. How many hearts are in a deck? It even tells you right here, 13. So 13 out of 52 is your probability of getting a heart. When a heart is drawn, you win $2. Yay! Smiley face. When a heart is not drawn, you lose. Okay, so there's 13 hearts, in which case you win. 52 minus 13 is 39. That's where I got that number. There's 39 cards in the deck that are not a heart. So you will lose 3 out of every 4 times. You will win 1 out of every 4 times. Expected value here is the profit times the probability of that profit. 2 times a fourth, negative 1 times 3/4. Add them up, you're going to lose 25 cents. Okay? So in this game, you lose 15 cents on average. On this game, you lose 25 cents. It says, which game should you prefer? In both games, you're going to lose, let's just be clear. But you're going to lose less in game one. So don't gamble, folks. All right. Last one. You've got another company. They're deciding if um, it's a cell phone company, and you know the first thing that goes bad on your cell phone, the thing that makes you need to kind of give up on it. I shouldn't say the first thing. But one of the things is that your battery doesn't last anymore. Okay, so you can buy warranties for your battery. Okay, it says here that you buy your smartphone and the battery is the lifespan of the battery is approximately normal with an average of 30 months and a standard deviation of 8 months. 30 months is what, like 2.5 years, which is about right. That's how long a phone kind of lasts before the battery starts to just not keep up. For the price of $50, the company offers a 2-year warranty. 2 years is 24 months. Okay. Um, and if you buy that warranty, they will replace your battery within 2 years. Okay. All right. Part A says, in how many months from the date of purchase is it expected that 25% of the batteries will no longer work? So that's up here. This is the distribution of the lifespan of the battery. It said that the average was 30 months. The standard deviation was 8 months. So I went plus 8 to get 38. I went, ooh, I did that wrong. I better have to fix this. Um, I'm sure some of you probably caught that. So I go minus 8 to be that. Okay. Well, that would just be plus 1 standard deviation or minus 1 standard deviation. The question is, um, what is this line where 25% is down here? Okay, I want to know what that is. And you can kind of tell it's in here somewhere. It's between 22 and 30. So I need to find the z-score for 25% from table A. I'll do that for you. It's going to be negative 0.67. So table A again. Oops, wrong one. Where is 25%? It looks to be right here is the closest. This one's close, but not quite. Okay, so that would be, whoa, 5. That would be negative 0.67. Okay, that's 25%. So I got the z-score. Then I work backwards. I know that z-score came from some number of months where the battery died, minus the average divided by the standard deviation. Ooh, the standard deviation is not 6, though. The standard deviation is 8. So I think I'm going to have to fix this one. I probably have an email or a message from one of you guys already saying, I found a mistake. Give me extra credit. And I get it. That's fine. So plus 30. So 24 would be the average, not 25. 24.64 months, which would be down here. Okay. So, which would change my conclusion. After 24.64 months, it's expected that 25% of the batteries will no longer work. Okay. Down here, this is months. Okay. All right. What else am I going to have to fix? Shoot, this one too. All right. Letter B. Um, what's the probability that the customer selected will require a replacement within 24 months? Meaning in less than 24 months. So I need to fix this. Well, that is, no, I don't have to fix that. 24 months is fine. What I need to fix, you might see my work here, I divided by the wrong standard deviation again. It should be a standard deviation of 8. So 24 minus 30 divided by 8 is negative 0.75. Oh, bummer. So it's not as nice as I thought. I had thought I could use the empirical rule, but I can't because it's a decimal. Okay. So table A is going to give us what? I'm going to look up negative 0.75 in table A. Negative 0.7 right here. 5. So right there. 0.2266. Okay. So this is, I'll put it as a percentage, 22.68% in this red shaded area. Okay. There we go. Excuse me. Okay. See, the company has a gain of $50 for everybody that purchases a warranty but doesn't require a replacement. They lose, if they have to replace your battery, they lose $150 for each customer who purchased a warranty and they need their battery replaced. So what's the expected value? Okay. So I made the table here to describe the situation. So if your battery fails in less than or equal to 24 months, I need to update my percentage. This percentage goes here. Okay. So that would be 0.2266. What's the complement of that 0.2266 is 0.77. So I have to fix this, right? Your battery is either less than 24 months or greater than 24 months. It's not, these are complementary events. So this would be 0.7734. Okay. So that's better. These are the probabilities your battery either fails too soon or it lasts. If it fails in the first 24 months, they will replace it. If they replace it, it costs them 150 bucks. If it lasts more than 24 months, they don't replace your battery. They take your $50. They say, thank you very much. See you later. Okay. This is the company's profit. Now, for the expected value, this is the overall question. Like, is this going to be good for the company? And I need to go back in here and adjust my numbers because they're wrong. I need to put in the right percentages. So this was 2266. This was 0.7734, which is going to change my expected value. Come back, calculator. Negative 150 times 0.2266 plus $50 when they don't replace your battery, and that happens about 77% of the time. Well, look at that. $4.68. Woo! They're making big bank. Well, I'm kind of joking, but kind of not. Think about this. If you're Apple, how many millions of people are buying this warranty? And if you make about $5 off of every single person that does this on average, you're going to make money. All right. So thanks for listening. That was a long video. Holy smokes.